today's masterclass with Apacer Technology. Today, two of our guest speakers, David Chung and Jamie Su, will showcase the latest advancements in DRAM technologies and SSD innovations designed for this year, 2025. And after the webinar itself, one lucky attendee will be chosen to receive a special Apacer gift, which is here in my hand. It's a Apacer screwdriver. I checked it myself. It's pretty nice. So I'm sure that it will be a nice present. Some basic information, as usually. The questions will be asked after the presentation itself to maintain the flow and the uninterrupted nature of the presentation. So I would like to encourage you guys to write the questions into the chat or to the Q&A, and they will be answered after the presentation itself. And yeah, this is all from my side. David, welcome again. And I would like to present you the starting point. So please, you can start the presentation.
Okay, thank you. Okay, can everybody hear my voice okay?
Yes, all good.
Great, thank you. Hello, everyone. My name is David. I'm the project manager at Apacer, mainly responsible for industrial products. I've been in this industry for nearly 13 years now, and I hope today's event will help you guys to know more about this industry and our brand as a trustworthy partner. Today's topic is Evolve with Edge Computing. I'll briefly go through how application is changing and our reaction toward these changes. Okay, so my agenda will cover three sections. First, we will talk about thermal management for SSDs and how did we implement our technologies on both firmware and hardware. Second, I will introduce a new technology that we have just recently developed and made its first debut at Computex last month. And last, I will share some successful cases that we have done in the past. Okay, so before we begin, I would like to take a moment to share some quick facts about Apacer with you. Apacer was established in 1997, and we have been in this business for over 27 years now. And we have 6 subsidiaries in China, California, Japan, India, and Netherlands. And our 3 main business scopes is industrial, consumer, and emerging applications. We are now the top 5 of corporate governance evaluation in Taiwan. And overall shipment has reached 385 million for SSD and DRAMs. And our total revenue in 2023 is $244 million US. And here are some of our main partners, because we are in the memory business and including NAND flash, controllers, and DRAMs. Our key partners have Kioxia, Micron, Samsung, SK Hynix, SanDisk, MeasureTech for controller, and Phison Silicon Motion for controllers. All right, so before we begin, I'd like to share the architecture of cloud and edge applications and how are they different from each other. In the past, devices communicated directly to cloud, where data storage and processing take place. The disadvantage of this is that data processing usually takes longer, exposing itself to vulnerabilities while data is transmitted. And now, edge applications are developed that acts as an intermediate station at much smaller scale to process data more quickly based on the application types, so that users can have lower latency and faster response from servers. This will overall result in more smooth operations. Here are some examples of edge IoT applications, such as automation, farming, healthcare, grid systems, transportation, smart homes, smart cities, and smart retail applications. Now, I've summarized some differences between cloud and edge and marked them in red. Generally, cloud computing is suitable for non-time sensitive, far away, large-scale applications. Overall cost is high for and required storage capacity is higher. The main purpose is to store data. For edge computing, every millisecond counts. Close to users, smaller scale applications, cost is relatively low and storage requirements smaller. Main purpose is to process data instead of storing. And with that being said, we know that edge computing will need a higher transfer speed to fulfill the requirement of data processing, which is also why storage interfaces evolved from SATA to PCIe. But of course, although PCIe SSDs are fast, it also has its pros and cons. And this is the reason why we have decided to dig deeper on thermal management. For PCIe SSDs, there is a built-in firmware technology called thermal throttling. When device is running at its full speed, it can easily cause SSD to overheat and lead to the following three most common problems. 1. Operation instability due to performance drop. 2. Reduced lifespan. And 3. Data integrity risks. Thermal throttling is designed to lower product performance when it reaches a certain temperature threshold and allows SSD to cool down. After it drops down to a normal operating temperature, SSD will resume back to its full performance level. In order to prevent the triggering time of thermal throttling, we have developed two types of hardware heat dissipation designs. The first one is applied a two-piece graphene sheet heat spreaders. This is one of our patents called the Core Glacier. The reason for this two pieces design is due to controller usually generates more heat than the NAND flash. So we have separated our heat spreaders to two pieces to prevent controller heat transmitting to NAND flash. This can maximize the protection of previously stored data. The one on the right is aluminum type heatsink. Thin design with airflow is the best way to adopt this design. If customer's application does not have a mechanical interference, then this will be an ideal solution. And here's a brief comparison about the results after our SSD is applied with heat dissipation designs. Graphene sheet is improved by 3%, while heatsink is improved by up to 20%. And we have the one in the middle that says slim heatsink. This one is also a thin type heatsink design, but smaller in size. Okay, so a while ago, I've mentioned about the timing of thermal throttling will be triggered. If you see the chart on the left, you can see that blue line is the TT triggering time after heat spreader is applied. Comparing to the SSD without heat spreader, it doubles the time for SSD to perform at its best performance before thermal throttling is triggered. On the right is the before and after of the thin type heatsink is applied. With the right platform configuration, TT may never be triggered. So I've used a different illustration and show you the actual temperature measured from the SSD. After heatsink is applied, the junction temperature of controller dropped down from 58 degrees to 38 degrees. The NAND flash dropped down from 40 degrees to 28 degrees. Aside from hardware, we have also made some improvements on firmware level by adjusting read-write speed. By doing so, another advantage is that we can also lower the power consumption of the SSD, killing two birds with one stone. And another firmware adjustment we have developed is dynamic thermal throttle. Simply put, the standard way for thermal throttling has two levels of performance degradation. For example, if a SSD's max performance is 3,000 megabytes per second, the first degrade will come down to 2,000 megabytes per second, and the second degrade will go down to 1,000 megabytes per second. And dynamic thermal throttle utilizes firmware algorithms to expand 2 levels to 4 levels. Although the range is still from 3,000 megabytes per second to 1,000 megabytes per second, but it has a more sophisticated handling method, allowing SSD to prolong its performance level and not dropping down too quickly. And here are some actual test results by adjusting read-write performance. You can see that after performance is reduced, power consumption can be saved up to 55%. We can see in in the performance section, if nothing is changed, the sequential read can reach up to 3,700 megabytes per second, and the sequential write is 2,800. But the first level of degradation, the sequential read will drop down to 1,800, and the sequential write is 1,600. And when it drops down to the first level, you can see that the power consumption has also dropped down 40% on read and 47% on write. And this page shows the performance variations when four-level thermal throttling is applied. This is actually quite a lot of information. You can see on the top right here, there's different levels of controller's junction temperature. And the below chart shows the temperature range of the SSD and the actual performance when thermal throttling is triggered. So if anyone is interested, we do have a test report to share with you. So you can contact our distributor SOS for more test results, and we'll be happy to share them. And next, we will talk about CoreEnergy. What we talked about in the first section is basically customer brings to us their requirements, and we customize firmware or hardware for them. Sometimes it can be very time consuming. CoreEnergy is the perfect alternative for what we have just talked about. With modern application designs, fanless and more compact designs are getting more and more popular, but it can cause SSD to overheat under long time operation. Handheld devices are typically powered by batteries, so how to ensure a device can be used as long as possible without SSD draining too much power from the device? This is our goal. And the last one is harsh environment. Long-term exposure can be harmful for both edge devices and SSDs. Here's an illustration of a knock-on effects. Faster speed, device will get hotter and power consumption will be higher. Slower speed, device will stay cool and the power consumption will be significantly lower as well. Our CoreEnergy SSD implemented both hardware and software trigger methods. The most beautiful part about this is that user can customize performance settings by themselves. We have also developed a friendly UI for users to monitor current setting of the SSD. Like this page is showing, software shows now SSD is configured by hardware, and we have a switch on this M.2 2280 SSD that you can change the performance settings by flicking the switch. Below are the 5 default combinations of our settings. You can see here it says best performance, performance, balanced, eco, and ultra eco. And here are the positions of the switch that default when the 3 switches are on top, that means on. This is our default setting, and SSD will run at its full speed. And the third switch, if you flick it to off, that means it will change to the performance setting, which is the second level. And I will share more details with you at the next page of how each settings are influenced to the SSD performance. So for software, we have 2 types of settings called the intelligent setting and advanced setting. For intelligent setting, it has 5 different modes, same as the hardware. And while under best performance, SSD is running at its full speed. And performance level, the performance will degrade by 30%. Balanced, performance will degrade by 50%. Eco, performance will degrade by 60%. And ultra eco, performance will degrade by 80%. These performance settings are achieved by adjusting the clock of controller and NAND flash. Advanced setting allows users to adjust the gen of PCIe and the lanes of PCIe as well. Gen is optional for Gen 4, Gen 3, and Gen 2. PCIe lanes is by 4, by 2, or by 1. These can all be customized. And the last part is access mode. Here we have selected from the intelligent setting, we have best performance, balance, and ultra eco. So on the third section here, it generally adjusts the clock of NAND flash. So by doing this type of customizations, customers can change up to 27 different combinations. Here are the test results we have done on our model PV250-M280, 4 terabyte. You can see that when it's running full speed, rewrite speed is over 3,000 megabytes per second. But when you change it to balanced, performance is left with 2,200 and 1,700. Power consumption is reduced by 30%. When you change it to ultra eco, performance is now 1,100 and write is 500. Power consumption is reduced up to 67%. Our target customer for this technology is those who has an edge device and they care more about power consumption and heat more than SSD performance because they might not need that much speed to fulfill their daily behavior. Then adjusting speed will not be a problem for them. Okay, and since CoreEnergy is a new technology, we do not have any successful cases at the moment, but we did have some experience with firmware adjustments. Now let's take a look at some of these cases. Applications such as multimedia, electronic whiteboards, retail POS machines, or IoT drones are some of the typical applications that our firmware adjustment might come in handy, since they do not have a large amount of data constantly written to the SSD. First case is ultrasonic machine for medical usage. We have applied a two pieces heat spreader in customer's compact design application to help with heat dissipation, prolonging SSD usage at a stable state. The second one is a vehicle electronics. Due to ambient temperature is very high, we have applied a fin-type heatsink for hardware heat dissipation. And also we have applied a dynamic thermal throttling, the one we previously talked about, the 4-level thermal throttling, to this application for firmware enhancements. And our SSD can operate smoothly under this type of harsh environment. The third one is compact size electronics. This customer has a platform that two pieces heat spreader isn't sufficient enough for them, but not enough room, but they also don't have enough room for a fin-type heatsink. So what we did is develop a mini-size fin-type heatsink. Although it doesn't perform as well as the full-size version, but it's enough for their application. And here are some bonuses that I'd like to share with you. In the past, most systems are built based on the x86 configurations, but in recent years, more and more applications are starting to adopt ARM-based systems, and NVIDIA is one of them. In order for us to improve compatibility, we have purchased several NVIDIA platforms such as Jetson and Orin that are used for various types of applications, so that Apacer can ensure our products with maximum compatibility with modern platform developments. Some might ask, when will Apacer conduct these tests on NVIDIA platforms? Whenever we have a new controller model, or we have a new flash manufacturing process or density, like right now, our biggest NAND flash partner is Kioxia. The mainstream of Kioxia right now is BiCS5, but the latest technology is BiCS8. So when we adopt BiCS8, we will conduct all of these NVIDIA tests again. And also, whenever we have a new firmware version, or if we have an upcoming PCNs, these are the timings that we will conduct the qualification tests on NVIDIA platforms. So these are my parts for the SSDs, and now I will switch to gaming for DRAMs.
Hi. Good evening, everyone. Thank you all for being here. I'm Jamie, the product manager of DRAM in Apacer. Today, I'd like to talk to you about DRAM products. My presentation is divided into three parts: the current market situation, new product technology, and the case study. First of all, I would like to give you an overview of 2025 DRAM market and the emerging demand. Start with the market share of general market. Obviously, the proportion of DDR5 was larger than DDR4 since 2024, but for industrial market, DDR4 are still have a big share. Why? Because we need more stable performance for industrial system. And let's talk about industrial market deeply. Due to the highly cost of DDR5 and the limited platform support, the market share of it keeps low in 2024. As we know, most of industrial systems focus on the stable performance rather than the high frequency. So there is nothing to trigger them to use DDR5. But in the first half of 2024, the DRAM vendor announced to phase out their DDR4 production line and shifted to DDR5 in succession. So we predict the proportion of DDR5 market share will up to meet 15 to 20%. Based on the platform migration, Intel and AMD's new platforms have begun supporting DDR5 with some even DDR5 only. In summary, DDR5 is going to be the mainstream in the future. Let's move on to innovation in next generation memory technology. We will talk about new products which have been discussed recently. First, what are CUDIMM and CSODIMM? In short, CUDIMM and CSODIMM are the updated version of UDIMM and SODIMM, aimed to keep the module performance in high frequency. JEDEC defined to add two key components while the module frequency up to 6,400 or above. One is CKD, client clock driver. The other is TVS, transient voltage suppressor. So what do CKD and TVS do? As the module frequency get higher, that will cause the back signal. CKD is purposed to strengthen the clock signal and improve the reliable operation. And TVS is added to protect our module to avoid the key component be damaged by the transient voltage surge. Both of them are used to enhance the durability and the stability in high data rate. And currently, these new client DIMMs are supported by Intel Alloy platform with 800 series chipsets. And if you want ECC function, then the WAA60 is your only and best choice now. So please feel free to contact our sales if you need samples. And next, have you ever heard about the memory wall? It describes the differences between CPU and memory development. As each new CPU generation appears, compute performance grows dramatically, whereas DRAM bandwidth improves only slowly because CPU and memory performance advanced at different rates. The rise of high performance applications make this gap even more obvious. So, how do we solve this problem? There is a new product born. We call it as MRDIMM. In the past, we can only read or write the data once per time, but in the future, we can send or write twice in a short time by adding two key components. The MRCD sorts DRAM commands and routes them to the correct rack. Each MRDIMM has 10 multi-data buffer that convert a 16-bit DRAM link to a faster 8-bit host link, while also isolating load to support more capacity and racks. That is to say, MRD must have these components to be MRD. Compared to the general RD, MRD can achieve a multiplied data transfer rate without increasing the number of channels. This helps solve performance issues in high compute applications. Let's move on to the next new product type. The last new product that I want to introduce is CAMM, compression attached memory module. CAMM was originally launched by Dell to apply in their own product. This product concept aims to be thinner and offer improved signal integrity, addressing the issues that SODIMMs may face. Later on, they suggested this product to JEDEC, hoping it would become an official standard, and that's how JEDEC ended up naming it CAMM2. The main differences between SODIMM and CAMM2 is the connector. CAMM2 has metal pins on its back that match directly with matching pins on the motherboard, as you can see from the right side of this slide. And because of the difference of connection type, the circuit trace of CAMM2 can be shorter than SODIMM. Shorter traces means lower power consumption. Also, CAMM2 have smaller layout place than SODIMM. There are more key features of CAMM2, and I will give it a deeply introduction on next topic. So let's go through case study. CAMM2 comes in two versions distinguished by the memory ICs they use. DDR5 CAMM2 reaches larger capacity by extending the PCB. Low power DDR5 CAMM2 delivers higher frequency, lower power consumption, and that can larger their capacity by stacking IC. Different product features can meet diverse application needs. DDR5 CAMM2 from desktop and high performance server. Low power DDR5 CAMM2 for thin and light laptop. But at this moment, the benefits of low power DDR5 CAMM2 are more worthy to develop first. Overview the strength of low power DDR5 CAMM2. Higher bandwidth performance, replaceable, upgradable, lower power consumption, higher memory capacities. The key strength is that it is upgradable and replaceable. As we know, notebooks used to rely on onboard ICs due to size limitation, but there were hard to repair. Any issue often means replacing the entire motherboard, which was cost highly. Now, with low power CAMM2 in a modular form, upgrades and repairs are much easier and more cost efficient. So, we anticipate that low power DDR5 CAMM2 be the better choice for AI PC. Currently, there is only one product supports low-power DDR5 CAMM2. It's a notebook produced by Lenovo. However, we've received strong interest and many requests from our customers. We expect significant shipment value to begin next year. The final part of the briefing is MRDIMM. Intel recently announced that its birth string will support MRDIMM, with the official launch expected in the second half of this year. To present, the next generation of MRDIMM frequency is planned to reach 12,800 with the introduction of MRDIMM. The future of AI and HPC applications becomes much more achievable. Its high bandwidth and efficiency make it the ideal memory solution to meet the growing demands of next generation computing. And that brings me to the end of my presentation. Has anyone got any question? Okay, thank you for your participation.
So thank you very much for the presentation, both of you. We have some questions in the chat. David, can you confirm you can see the questions, please? Either you or Jamie, can you just confirm you hear me?
Yes, I can hear you.
Yes. So
Okay, so
questions in the
should we
chat.
go through the questions from the chat box?
Yeah. Just feel free to go through them.
Okay, so I see the first question is, which SSD series offer hardware CoreEnergy? The CoreEnergy is available in our model called the PV250-M280. Right now, we only have the M.2 2280 form factor that supports this technology. And in later stage, we will also have M.2 2242 and M.2 2230 to support this technology. Okay, does CoreEnergy software support Linux? If customer is operating under Linux OS, it can be supported, but right now it can only use hardware trigger because our software utility is Windows only right now. Okay, the third one, how is influence of CoreEnergy to IOPS performance? Regarding IOPS, it will be degraded definitely, but we didn't actually, this is in another test result, and we will put it in our spec for the actual IOPS performance, but same as sequential performance, it will be degraded as well. Is PV250 with heatsink a standard product? If not, what is the MOQ? PV250 is default with the 2 pieces heat spreader as our default. And the fin type heatsink is an optional product. And right now, the MOQ, we didn't set much. Sample doesn't have MOQs, but when customer is going into mass production stage, we will hopefully set the MOQ at around 200 pieces. What SSD performance loss can we expect if SSD will work at ambient temperature around 85 C? Regarding this question, I want to know that, are you talking about the, without any type of firmware adjustments, just by the native thermal throttling? Or if we are talking about, how to say that? If we're talking about utilizing the CoreEnergy technology, or if we are talking about customize the firmware, then the SSD performance drop can be expected. But if we are talking about the native thermal throttling mechanisms, based on different capacities, we do have an application note that with the actual test results for product under 85 degrees Celsius. So, Mr. Miroslav, if you have any specific queries on the model and the capacity that you are asking for, you may send the inquiry to us, and we will send the relevant relative application note to you, so you can see the actual SSD performance when it's under 85 degrees Celsius. And what SSD type form factor provides the best performance if temperature inside the embedded system case reaches 85 degrees Celsius? But this is a very general question, and it's kind of hard to answer because I'm not sure how do you define best performance. So also, I think if we will have a specific model and more detailed information, I think I will probably answer this question more precisely. Some embedded systems work at an ambient temperature up to 85 degrees Celsius. So temperature inside the case can be higher than 85 degrees. Do you have an SSD for such an embedded system? Okay, so for our SSDs, even though 3D NAND from our manufacturer, Kyoshia, they are stating that their 85 degrees Celsius is basically based on the case temperature of NAND flash. But when we, Apacer, we conduct our temperature test, we set our chamber ambient temperature at 85 degrees Celsius. So basically, the NAND flash temperature will go up to 90 or even 95 degrees Celsius. So we are confident that it can survive under such environment. 96 gigabyte PV250 M.222 has max power dissipation 4.3 watt in PCB area only 9.2 centimeters squared. 4.3 watt is a lot for such a small area. How effective is the graphene heat spreader compared to a solution without a heat spreader in the aluminum heat sink? This one I would like to clarify first. The heat, the temperature that we measure from our product is the junction temperature of NAND flash. We do have a thermal sensor in the controller. We have another one in the NAND flash, and we also have one on the PCB. But our key factor is on the NAND flash. And because PCB are the heat mostly are generated from controller and flash, and PCB is actually measure the composite temperature of the whole finished goods. So the heat dissipation on PCB area is actually not a big concern for us because, like I said, if the ambient temperature goes up to 85 degrees Celsius, for example, the NAND flash can go up to about 90 to 95 degrees Celsius, and the controller can go over to 100 or 110 degrees Celsius. So the controller and NAND will be our most concerns, and PCB itself, without active components, it doesn't generate much heat. So if customer doesn't have mechanical interference on their platforms, of course, they can adopt the aluminum heat sink.
Can we use CSODIMM DDR5 for embedded system that uses standard SODIMM DDR5? Yes, but it depends on the platform that you use. If the platform doesn't support CKD mode, the system may bypass CKD mode automatically. And the next one, can you mention example for embedded system that use CAMM2 modules? As I say, CAMM2 is a very new module type. JEDEC just released the official version last quarter, so there are not any cases can share with you now.
Do you see demand for CF Express and 2.5 inch with PCIe interface and U.2 connector? Yes, we do. Right now, we do have several projects that are designing in the CF Express and U.2 in industrial applications. But right now, we do have some small projects with wide temp U.2, and also there are many customers that are choosing a PCIe U.2 or U.3 is because they want a very large capacity. And most of the inquiries we have received now are actually for enterprise products. But for CF Express, we have some applications for gaming devices and cameras. So yes, we do see a potential for these two form factors.
Okay, David, thank you very much for the really nice answers to the questions. And I really hope that it helped. I would like to encourage everyone that if you have any additional questions, feel free to send them over to either our sales guys or David himself, and I'm sure that he will be more than happy to help. I would like to thank you all for joining us today, and thank you, David and Jamie, for the very nice and professional presentation. It was really interesting, and I'm sure that everyone will took something from it. We will, after the webinar, find out the winner of the gift. So yeah, make sure to keep an eye on that. And I would like to wish everyone a nice rest of the day, a successful day. And thank you again for joining us. See you at the next webinar. Thank you. Bye.